Alright, I hope you've seen the previous video. To practice the ideas, we're going to take a look at sine of 7 pi over 6 radians, and we'll also look at cosine of the same angle, 7 pi over 6. To start, you can draw a unit circle. And these axes lines don't really matter, but we're looking at something pi over 6, so imagine cutting the entire unit circle here into 12 equal sized pieces. If that's so, there's 6 pieces on the top and 6 on the bottom, so there's 0, 1, 2, 3, 4, 5, 6, 7. So that's the angle we're looking at. And if you look at the 3 special points that are in the third quadrant, there's one that's right in the middle that pierces halfway through. That's the one that's related to the 45-degree angle. But we're looking for this one right here. And you can take this point and flip that up here, and eventually that would flip back here. And if you draw this is actually just a straight line back. This is a 30-degree angle right here. And we should just basically use the information that's right there. So for 30 degrees, remember that you have, well, of the 3 special points in the first quadrant, this point is the furthest over to the right, so it has the biggest x value at root 3 over 2 and has the smallest y value at root 1 over 2, or just a half. And we can take that information and copy this into the third quadrant. This point right here has to actually be, well, basically the same numbers, but third quadrant, so both are negative. Negative root 3 over 2 and negative root 1 over 2. And now we can find sine of 7 pi over 6. So that's just the y coordinate here, right? So to get sine of 7 pi over 6, that's just this number, negative a half. And finally, cosine of 7 pi over 6, well, that's negative root 3 over 2. Just to make sure that we're writing things like this carefully, we'll just write down one of these. Cosine of 7 pi over 6 is equal to negative root 3 over 2. You don't want to do things like, say, cosine of negative root 3 over 2. Make sure it's cosine of, and then the angle, then an equal sign, and then the number. Let's try this again. Let me just clear the screen here. And we'll try this again now, but for, how about, we'll look at the angle 7 pi over 4, and we'll find the sine and cosine values again. So draw a unit circle. Alright, well, now we're looking at pi over 4s. There are 8 of them in the unit circle. Pi over 4 is 45 degrees, so if you look at 45 degrees, there are 8 copies of 45 degrees. So there's 1 pi over 4, 2, 3, 4, 5, 6, 7 pi over 4 is right there. That's the one that pierces halfway through the fourth quadrant, so we're looking for the coordinates of this point. That's related to the coordinates of this point right there. And here, whoops, this point has coordinates root 2 over 2, and then comma, again another root 2 over 2. So the coordinates of this point, because this pierces exactly halfway through the first quadrant, you have these equal x and y values. We can copy these numbers over here. Positive root 2 over 2, that's correct for the fourth quadrant, but then we do need a negative y value in the fourth quadrant, so negative root 2 over 2. Now we're all set to write down the sine and cosine values of this angle. So looking at, if we're trying to find sine of 7 pi over 4, well, we're going to need the y coordinate right there, so that's negative root 2 over 2, and then finally cosine of 7 pi over 4 radians will be the x coordinate of this point right here, so that's positive root 2 over 2.